Testing 1 2. Check test 1 2. I'm going to start. What? We got to start what?
I got my presentation for next month. USB?
Later. Yeah, I'd like for you to just email it to me.
It's pretty big.
I'll give you a Google Drive.
Okay.
Yeah, I don't have a computer here. This is actually Trevor's. Oh, you want to leave it with me? Yeah. Okay, I can do that. I didn't understand. Sorry. Okay, so we are going to get started. It is 7:30, and welcome to the March meeting of the Johnson Space and Astronomical Society. I'm Doug Holland, and we're going to have a different kind of meeting tonight. So this is our agenda. Okay, so we're first, what? I told you we're gonna have a different kind of meeting tonight. I'll say it a third time. We're gonna have a different kind of meeting tonight. Okay, so you guys know we've been trying to stream this meeting and do it live for a long time, and we're learning as we go along. And our audio for the last few meetings has been terrible. It's just been, the live audio has been awful. So we are not using this mic anymore because we are determining this thing was wired out of phase with the room mic. So basically, what happened was everyone in the room sounded great and the speaker sounded terrible. So tonight, we're not using any of it. We're using the microphone on this laptop. And all of our speakers tonight, you got to talk pretty loud because there's no sound system. Okay? So if you're a speaker, we normally have a mic for you, but tonight try to be loud because we're not using any mics. The mic for the stream is this computer and no room sound system tonight. Okay. And so for our agenda tonight, we're going to have James Wooten with the Houston Museum of Natural Sciences going to tell us about the eclipse, which is 1 month from yesterday. Pretty cool. And then, believe it or not, we're going to have a member's minute from a young lady who's in the United Kingdom. And she's going to remote in, and she's going to tell us all about the zodiacal light, Rosanna Howard. And then we'll have Phil is going to tell us about his 2023 eclipse movies that he has done. And I'm going to tell you some more about radio astronomy because, I know you guys were really disappointed that last month I didn't tell you anything about radio astronomy, and I saw the sad looks on all your faces. So tonight I'm going to make up for that and show you another radio astronomy project. Then we'll wrap it up with David, and then we're going to have some really cool door prizes that were donated by Chris and Angie. Then we'll all go to Mod Pizza and make ourselves sick eating pizza in the middle of the night. So, all right, we have a couple of different email distributions here. One of them is just for meetings only, which you send to Ron, who's that gentleman back there that just asked me about the microphones. And we have, that's just meetings only. And there's David, which is over here, and he has an email distribution for a general email distribution for other topics. So you can either take a picture of this and send the email to these either for meetings or for general distribution, or somewhere at the back there, I hope, there's a clipboard right by Bob that you can tear off one of these little tabs and you can sign up for the email. How's it sound, Trevor? Good. All right. Trevor says it sounds good. So that's the two email distributions. And if you aren't getting our emails and you want to, that's how to get signed up. So the easiest thing to do is go back there and tear off one of those little tabs and sign up and go. Now, before we get started, I want to go around the room and I want to ask if there's anyone that's new here that wants to admit that you're new. First time here. It's not Chris. He used to be the president. Don't tell me that. And first time here, and tell us your name, how you found out about us, and what your interest is in astronomy. Right there.
I'm Nick, and I found out about you guys through the roundup. And I've been interested in astronomy since I was a child. So.
Excellent. Well, we're glad you're here. Who else? First time here. You guys.
Aaron and Mary. Let's see. Been interested in astronomy your whole life. I used to be in the roundup all the time, but I've also seen you in the Houston Chronicle recently. So,
really?
Yeah, like in the Wednesday section where they do the local, they kind of talk about stuff going on, and it popped up the one over at Mater the other night, so that was in there.
Is that right? That's in the Houston Chronicle? Oh my goodness. Well, we're doing better than I thought. So, what was your names again?
Aaron and Mary.
Aaron and Mary. Okay, great. You got a telescope?
Yeah.
Excellent. That's good enough. All right, we're glad you're here. Did you want to say anything profound, Mary?
Do I want to say anything profound?
Yes.
No.
Okay, fine. Anybody else, first time here, do you want to admit? Right there.
I'm Nathan Price. I also found out about it from the roundup.
Woo-hoo.
And I guess today I'm really interested in radio astronomy.
Oh, good. There's like about three of us. Okay, so yeah, excellent. No, there's actually more of us. There's about let's see, 1, 2. There's about 5 of us. They're really 6. Oh no, you're interested in radio astronomy too? No, you just want to tell us your name. Okay, right there.
John Rodriguez, Quinn told me about the meeting. Certainly I'm interested in anything that's wrong.
Well, we're glad you're here. John Rodriguez and
Quayle.
Quayleen.
And I found out about it on Meetup. I haven't ever been to Meetup before, but had no science in my background. I went to like schools for ladies and girls. And that was quite a long time ago, but I found all of these groups like science enthusiasts. That's one group, and so I'm sort of getting in my science. I love it. I'm getting exposed to all kinds of new things.
So you found us on Meetup?
Uh-huh.
What is Meetup?
Well, it's just like a dating thing, but it's not about dates.
We're on a dating service now?
No.
Hey, no wonder we've been getting so many new members. What? Okay, what?
There's all kinds of categories, and you can just go and sign up for a meeting, and
Okay. Did anybody know how we got on Meetup?
It's kind of like a hobbies app
Okay,
for people that are like
yes.
like-minded.
Are you new?
No.
Felix here.
Okay, I'm going to find out about you because you don't look familiar. Okay, right here.
Ron Coleman, I enjoy astronomy, more from the radio frequency perspective though. I'm a electrical engineer, I work at NASA JSC, and the EMC group.
Ooh, so look, we got like 4 people now interested in radio astronomy. You interested in radio astronomy? You said the radio, right?
Yeah,
Yeah, so that's radio astronomy. Yes?
and I found this through Meetup as well.
Oh my goodness. Okay, well, as long as we're on there, that's all that matters. I have no idea how we got there. Okay, you that knew who you meet, what's your name?
Adriana, I'm in my uniform today, I'm sorry.
Adriana. Okay, great. Well, we're glad you're here. All right, anyone else? First time here or that we don't recognize you? No, nobody else. But you guys really put up with us. I appreciate your cooperation. Okay, good enough. All righty, so we're going to move on. Oh, to our speakers, remember when you use a pointer, don't use a laser pointer up here because nobody online can see it. Use this little red mouse pointer down here so people online can see what you're pointing on. We actually have, I mean, I'm glad we got a good attendance tonight, but we get like between 100 and 200 people online. So we're getting actually more online participation than in person each month. All right, now what you guys really probably came here for. James Wooten is going to tell us about the Great Texas Eclipse, but before James starts, I am going to tell you a little bit about him. Okay, James Wooten is the planetarium astronomer at the Houston Museum of Natural Sciences. He holds a BS in physics and a BS in planetary science from the Massachusetts Institute of Technology, an MS in astronomy from Rice University, and a Texas teaching certificate from St. Thomas University. James has been employed as a planetarium astronomer at the Houston Museum of Natural Science since 1995. In this position, he teaches fourth graders at HISD students each school morning. He gives planetarium shows about the night sky to the public, answers questions from the public about astronomy by phone and by email, gives media interviews about astronomical events such as eclipses, meteor showers, and transits, prepares all museum documents involving astronomical information, and prepares monthly sky events of the month emails for those interested. He's also an adjunct professor at the University of Houston downtown teaching solar system and galactic astronomy. So with that, join me in welcoming James Wooten.
Thank you for having me speak about this eclipse. I'm so excited about it because the moon's shadow comes to Earth fairly often, but comes to us almost never. Is anyone here making plans to go watch the eclipse, to watch the total eclipse? Okay. So if anyone has not made the plans yet, and you have an inkling to go, when I show you the path, see if you know anyone in that path, call them up tonight, rekindle your friendship, and ask if you can spend a weekend at their house and watch the eclipse on Monday, drive back on Tuesday. If you're not going to do that, if you're going to go to work on Monday, by the way, then be prepared. People are calling in sick. They're going to do that. I just suggest you do. Well, our first job is to understand why this is so exciting. And this is a demonstration I've done with kids and teachers, and it amazes kids and teachers as well. So you can replicate it. I have a typical classroom globe, which is 1 foot diameter. And I have a moon, roughly the scale. It's a little bit too big, but it's a moon globe, so I use this. My question to the kids is, how can I make the distance to the same scale as these globes? Where should I be? Tell me when to stop. Yeah.
Parking lot.
Right there. Right there. Actually, it's more like right here.
My
Because,
cabin ceiling tiles.
yeah. I didn't think of doing that when I said. I didn't know how many feet each one.
It's 2 feet.
2 feet, okay, yeah. So you just need 15 of them, because you see, if you wanted to do this with a group of students, the moon is 9.5 Earth circumferences away. So with a 1 foot globe, it's pi feet, the circumference, so 9.5 pi is about 30 feet away. Now, of course, what I can't draw on the scale is the sun, because the sun is 400 times as far from the Earth as the moon is. So if I'm 30 feet away from the Earth, the sun has to be 400 times that far away, 12,000 feet away, which is over 2 miles away. So I need someone to take a sun and go down to the JSC campus. Oh, by the way, the sun has to be 400 times bigger than this as well. That's the coincidence that gives us our solar eclipse. 400 times farther away and 400 times bigger across, which means 400 cubed times the volume of the moon. So that would be about 109 feet across. So I need a ball 109 feet across. How many feet is this room?
35 feet.
35, yeah. So it wouldn't fit in this room. And down to JSC campus to have the sun. And that's exercise to, because our challenge teaching kids this is that space is too big. We teach it wrong. We have to because we have to show it to kids. We draw it right, won't fit in anything. And we can't show them that. But the sun is over here. Of course, you all know what happened in October. We had the annular eclipse. That's because if I'm back here, the moon's shadow tapers off to a point before it reaches the Earth. And we couldn't see totality. The moon's shadow didn't land on the Earth, which you have to have a total eclipse. Also, most new moons are like this or like this. Like tomorrow's new moon is like this, which means the shadow will not land on the Earth. There's no eclipse. New moon of May is like this. The shadow won't land on the moon. No eclipse. So everything has to line up just right for us to even get an eclipse. But that's just one of the issues. Once you get the shadow to come to the Earth, there's no guarantee it comes to you. So I've been all over the world, and many people do go all over the world to watch eclipses because you have to go wherever the shadow is. You have to go stand in the shade to watch the event. I've been to Australia, Cairns, Australia, been to Shanghai, been to Madagascar, all in pursuit of the moon's shadow. But in 2024, it all comes to us. So again, the moon's shadow comes to Earth fairly often. It comes to you almost never. And that's why we're so excited about this event next month. It's 1 month from actually today, I believe, right? April the 8th, 2024. And that's where you have to be in order to watch the eclipse, the totality. So again, if you haven't made your plans yet, you have anything to go, look at the green path and ask yourself, do I know anyone who lives in that path? If so, call them up, rekindle old friendships, and ask if you can spend a weekend at their house. Drive out on Friday or Saturday, actually, spend the whole weekend there. Then drive back on Tuesday. Don't try to drive on Monday. I was actually in Wyoming for the 2017 eclipse. Yeah, I have my new t-shirt. And anyone who drove back on that Monday when the eclipse happened wasn't going anywhere. We were smart enough to spend the night, Monday night, to drive on Tuesday. But look at the odd shape. that eclipse is pretty steep, and to explain that, you have to understand the Earth is tilted like this, mostly to the side, but kind of toward the sun, because April is 3 weeks, 3 weeks after the solstice. So if you can look where North America is, if the moon's shadow does a straight path like this, it winds up doing that because of how tilted the Earth is. That kind of path happens when you have an ascending node eclipse in springtime or late winter. The orange path is for the annular eclipse in October. That happens on a descending node eclipse in summer or fall. Thus, the idea being that to have this happen, the moon must be at just the right height to line up with the Earth. And if it's coming from below the plane to above the plane, that's an ascending node. If that happens in springtime or right around the equinox, you get the lineup where the Earth is tilted in that direction. And so you get a straight path looks like this. Whereas if you get a descending node in the autumn, you get that. That's exactly what you're seeing there. So the shape of the path will depend on what time of year it is. If you're at the solstice, it'll be more of a straight path across the Earth. It won't go upward. It won't go north. Instead of going toward northeast or southeast, it'll go more towards due east or due west. Also, if you have an ascending node eclipse at the spring equinox or descending node at the fall equinox, it will level out more, like in 2017. But because we have an ascending node eclipse right just after the spring equinox, we're getting this path that tacks sharply up toward the northeast, goes from Texas into Arkansas and Missouri, then to Illinois, the Indianapolis, Cleveland. Buffalo is behind the 2 here, so the Buffalo is right on the path, as is Rochester. It nicks the southwest eastern corner of Quebec, into Maine, New Brunswick, and this doesn't show that it ends in Newfoundland. However, the weather prospects get progressively worse as you go northeast on that path. Like I mentioned earlier, we had an eclipse in October. The moon was too far away to actually block the sun, but my boss went to Bandera, Texas, made a movie about that eclipse. So this is kind of what you would see if you're stuck in Houston. You see something like this, because the eclipse in Houston will cover 94% of the sun. So anyone unable to travel to totality, yeah, this is the part they got depressed. Depression set in about here, but the story has a happy ending. Otherwise, I wouldn't be showing it to you. But you see, it did get noticeably darker. So even if you're not able to go to totality, you'll notice quite a remarkable phenomenon, because when the moon is covering even most of the sun, it gets noticeably darker. Although it never quite becomes night or even twilight. Still daylight, but the daylight looks like it's off. Did anybody watch the October eclipse? Did anybody remember how the daylight looked? It was daytime, but it didn't look right. Like someone had a dimmer. Yeah, you'll see that even more. That was 84% coverage, by the way, here in Houston. This will be 94% coverage if you're in Houston. And then the event wraps up. So that was how it looked. That was the annual eclipse in Bandera. So again, if you look at Houston, we're not in the green path, so we're going to see 94% coverage of the sun. In Katy, more like 95%. And of course, the ring of sun remained around the moon because the moon was not close enough to block the whole sun. And the shadow petered out before reaching the Earth's surface. Now, if you're looking at a partial eclipse, There are so many cool things to do. This is a woman standing outside the museum, and we had something with holes in it. We had this little board up here, had holes poked in it, so you see all the copies of the partial eclipse on her back. So anyone who's going to be stuck in Houston, or if you're going to totality, you can do this before you get to totality. For example, does anybody have a hat like this? I'm taking this to the range where I'm going. So if I have this hat, when the partial bases get pronounced, I can just hold this up and you'll see the hundreds of copies of the eclipse under the hat. You can make your own pinhole cameras. Anybody have a stopper in their house like this? Like a drain stopper looks like this? Yeah. Anything with holes in it, you hold it up and the sun will shine through it. These become pinhole cameras. And you get as many copies of the eclipse as holes. Something to appreciate as you're waiting for totality, even if you're in the path of totality. Don't have any of that, then do this. Make your own holes. You don't feel like doing this? If you have any trees, every leaf, the space between leaves will make a pinhole camera. And thus you can see multiple copies of the partial eclipse while you're waiting on totality. So is 94% really enough? I hope you're not saying this. Yeah. Because there are so many things that happen only in totality. Oh, by the way, if anyone would like some, I have some of these viewers that we're giving out to the public as well. So you can have glasses, of course. The eclipse glasses will be everywhere. But these are often more convenient because you don't have to worry about them fitting over your ear. Just look like this. And so if anyone would like one, I have some of these as well. These are your viewers that look at the sun safely. Don't be like Donald Trump, who's like this in 2017. Not how we do that. The amount of sun you can observe safely is 0. But if you ever go to totality, then that is safe to observe naked eye. That's about as bright as the full moon is. Thus, if you have that, take all the filters off. In fact, the filters will block that. Take everything off and look at that naked eye. You get, if you're in Texas, about 4.5 minutes, 4 minutes and 20 some odd seconds, 28 seconds, 26, 25, depending how far along the path you are. And that's enough time to see the corona, which is, of course, always there. At a time of solar maximum, you see a more rounded corona. If you were near solar minimum, you might have one part over here and one part over here. But at solar maximum, you tend to have more activity all around the sun, and thus you tend to have a corona all around the moon. I've noticed a lot of sunspots are on the sun now. Therefore, I should expect a round symmetric corona for this eclipse. Other things happen only in totality. For example, you can actually watch the shadow move in. Has anyone done that before? If you look to the west, right before totality, you can watch. You can see how it's much darker in the west than the east. You can see the shadow come in. You can see the shadow bands along the ground as they come in. Look for that on April 8th. You'll notice it gets cooler because you're in the shade now. And in April, it may be quite noticeable, may be quite warm on April the 8th. They'll get significantly cooler when the moon is covering the sun because it always is cooler in the shade. And in fact, one eclipse I witnessed in Shanghai, it was cloudy and overcast until totality. We noticed it got darker. You couldn't see the sun. It got way darker though. That was noticeable. And then, right in totality, the clouds thinned out. The lower temperature thinned out the clouds. I had never seen that effect. I had never known that would happen until I witnessed it happen to me in Shanghai. So we were able to watch the partial phases as the moon moved off of the sun. All we were clouded out for the totality of the eclipse. All kinds of important effects happen. Again, only in totality will you get that loss of temperature. Although it's a little bit cooler in October with 84% coverage, but when you're in the shade, it's not cool. Note the animal behaviors. Animals check out what's going on. We won't be in water, but if you are near the water, then you would see whales and dolphins check it out. Cetaceans are very smart. Nocturnal animals and crepuscular animals come out because they think it's twilight. In fact, when it does this, it's like twilight. Think of the sky like a few minutes, like about 30 minutes after sunset. All the brighter stars and planets are out. So you can look for, when this happens, you can look for Venus to the lower right of this, and Jupiter to the upper left. They'll come out even before totality, but once you get to totality, then look for Saturn and Mars to the lower right of Venus. You have all the planets come out. And you'll have, see the sky for that day, and I forgot to put it in here. I just didn't think about that until, but the sun's in Pisces, and this is happening at midday. Because here in Houston, by the way, it's 12:20 to start, 1:40 maximum, 3 o'clock to end. And since we're swinging forward tomorrow, don't forget, that's midday. 1:40 is midday. So all around Texas, it's happening near midday. Yeah, right. Every Sunday when that happens, I'm coming out of church, here comes somebody walking up. So don't be that person on Sunday. Make sure you spring forward tomorrow night. So you can see, if I can reconstruct the sky, you have Pisces and Pegasus on the horizon, on the meridian, with Orion rising, and Cassiopeia above the North Star. That's the sky you're looking at for totality. So you might try to see if you can see Orion stars rising up. Look around during the 4.5 minutes you have if you're in the totality. Summer Triangle will be over in the western sky. But the planets will be easily noticeable. In fact, I saw Venus come out noticeably and obviously during the partial eclipse in October. Venus, by the way, is always there. If you know where to look, it's always there. But during this, it becomes just obvious. It just pops out. And of course, the moon is not a smooth body, it has mountains and valleys. And thus, when the sun shines through only one valley, you get a diamond ring. Some eclipses have a chance of seeing two diamonds at the same time. That's because they're shining through two valleys at the same time, and they both disappear at the same time. If you have multiple valleys to shine through, those are called Baily's beads. Again, this happens only at totality. Because the sun's surface is so bright, it would just wash everything out. It's always there, just washed out by the sun. But when the moon covers all the sun, you get this. And by the way, when you're watching totality, when you see this happen, put the filters back on. That's not safe to look at naked eye. Only this is, but not this. So if you're going to go to the eclipse, remember, like I said, the weather forecast gets worse as you go northeast. Best weather forecast is in Mexico for the eclipse. Here in Texas, just north of 50% chance. April, it can be rainy, but we have the best chance statistically of anyone on this whole path. The chances get much lower as you go up here. Of course, those are just chances. If this had happened in 2023, Texas would have been clouded out and they would have seen it appear. April 2023 did not follow the statistics. But maybe we can knock on wood and hope April 2024 does follow the statistics and leaves Texas clearer than everyone else up here. But again, Mexico would be the best place to watch the eclipse. But Texas is almost as good, and we're right here, so we'll stay here. Yes?
James, I got a question for you. So across Texas, is it basically linear from southwest to northeast, or is there places within Texas which the weather is, is it
worse or better?
It's more or less linear. In fact, in the hill country where I'll be, the western part of the path is slightly better than the eastern part of the path.
Oh, really?
I'm gonna be in a ranch west of San Antonio, and the balcony is escarpment. And so that the elevation helps as well.
Right.
Yeah.
Okay.
But I'm not sure it's linear, but it's a continuous tendency, the trend, I should say.
Yeah.
Is not remarkable that as you go along the path,
Okay.
the weather prospects get worse and worse and worse and worse.
Okay.
But not zero, so it's possible they'll see it in Cleveland or Buffalo or Sherbrooke, Quebec. But the chances aren't as good. Also, the eclipse gets shorter as you go along the path. If you can see the black dot right here, this is where the eclipse is longest. That's because this is where the shadow hits the earth, like right here at Mexico. I'll put Mexico right there. And then as it moves on, there's more of an angle away from the shadow. So the shadow takes a little bit longer to get there, and it moves faster. In other words, you can imagine that the velocity of the moon's shadow with respect to Earth is slower when it's doing this and very fast when it's doing this. And that's why, right, when it's on the meridian at the maximum eclipse, you get a much longer eclipse because the shadow is moving as fast relative to the Earth's surface. But as you move away from that, the shadow is moving a little bit faster. And so the eclipse is a little bit shorter. Fortunately, we in Texas are close enough to that black dot, and now my pointer, that we're still going to see the black, right where my pointer is 4 minutes, 28 seconds. So where I'm going to be in Texas, it's going to be 4 minutes, 26 seconds. But as you get to here, it comes like 4 minutes. And by the time you get to Newfoundland, it's only a 3-minute eclipse. And of course, you want to be on the central line. As you go toward the edge, it drops off noticeably. It falls off like a sine wave. So it's a little bit of drop off as you move a little bit off the center line. So if you're not right on the blue line, it's okay. But if you're close to the red lines, you get a much shorter eclipse. For example, if I zoom in on where I'm going to be on a ranch, not in Utopia, but kind of close to it, right here. But you see in San Antonio, if you're in downtown San Antonio, you miss it. Well, you see a 99% partial eclipse. But if you go right to the line, you see a 1 minute eclipse. If you go up here to Six Flags, it's 2.5 minutes. You go up to Bernie, it's 3 minutes. You go to Kerrville, you get the full experience. Same thing with Austin. On UT campus, it's about a 1 minute eclipse because it's right next to the line. Come in to Horseshoe Bay, you get a lot more. So it falls off a little bit like this, then it really falls down very quickly as you get toward the edge of the path. The length of the shot, yes.
Where did you get this particular map?
Well, I got that map off of our webpage. Okay. Yeah, we have our. Anyone still wants to come with us? We bought a whole ranch to take people there. We have a couple hundred people with us, but we haven't filled the whole ranch yet. So you can go to our website, hms.org, and you can still purchase a bunk and come see it from right there with us.
But that map is on your webpage.
That map is on the museum's webpage showing everyone who buys our trip where you'll be.
I gotta ask you, what is Utopia?
Utopia, Texas is a small town. I haven't been there before.
I think it's a giant star.
Yeah. Yeah, I don't know. I haven't been there before.
It's pretty.
Yeah.
It's very pretty.
I don't know if
It's a giant star.
Yeah. I don't know if it is Utopia, but I've never been to it.
Okay.
But we'll find out. We won't be in Utopia itself. We'll be in a ranch that's near Utopia.
Okay, that's
It's called Lone Hollow Ranch.
All right.
That's where we'll be. So again, I'm not right on the blue line, but I'm close enough. So I'm going to get about a 4 minute, 26 second eclipse. Now, what if you want to see this again? Or what if we get clouded out this time? You can see it again pretty soon, like in 2026, but you have to go to Spain or Iceland, but I'd rather go to Spain if I'm doing that. Oh, by the way, if you're wondering how can you get a path like that, that's because it's August, so you have the Earth tilted, let's see, a little bit more toward the sun, more like this, and you have the path really doing this. See, that's a straight path for the moon shadow, but it's going to go over Iceland and Spain because the shadow is hitting Earth right here, and it's going like this. And it looks like that. That's a weird path for the shadow, but if you look at the curvature of the Earth and the tilt of the Earth, that's a straight path for the moon shadow as it passes the Earth. You can come with us. I'm leading another trip in 2027. We're going to Luxor. Yeah. But like I said before, the moon's shadow comes to Earth fairly often. It comes to you almost never. That's why I'm heartened to see that so many of us are taking advantage of this and making plans to watch the eclipse. And by the way, does everybody know the site where I got these from? A French guy. That's where I forgot to put that on the maps, but that's where I got all these eclipse maps from. Basically, he overlays the eclipse path with Google Maps. So you can zoom all the way in. If I had been able to surf the web, I would have shown you how to do that. You can zoom all the way in on any of these places and get precise values of the how much will be covered, the magnitude, and the obscuration for any location and all those times of all the context of the eclipse. So if you go there, you can do that for any eclipse he has on there. And that's the thing. By the way, don't forget to put this part in because his site is in French. If you do put the E in there, it's in English. But I know some French. I like to read the site in French just to amuse myself. And of course, after that, go down under. July of 2028. Again, this is to be the best place to watch it in Northern Australia, although the shadow does go to Sydney as well, and also to Southern New Zealand. But again, that's the edge of the path. You get to watch the eclipse, you want it to be in the central line on the center of the path. If you go toward the edge of the path like this, you get less of an eclipse. If you go to the edge like that, you get less of an eclipse. If you're wondering, the next eclipse that comes to touch Texas is 2045. He didn't have that one on his site yet. August 12th, 2045. I would be a 75-year-old man. So I'm gonna hope I see this eclipse. So I can, if I want to see one, and that one just nicks the upper top part of the panhandle, actually goes over to Florida. And that's if you do make it to that one, that's one of the longer ones. So it's a solar cycle where the eclipses repeat every 18 years. And the longest eclipses are the ones, for now, are the ones in that cycle. You had the one in 1991. Anyone see that one? 19 was in Hawaii and Mexico. About 7 minutes of the eclipse. And that repeated in 2009. It's also going to repeat in 2027. That's going to be over 6 minute eclipse. 6.5 minutes. And then the one in 2045 is 18 years. The one that's next Texas and goes over to Florida. That's the same, so it's over 6 minute eclipse. So you can watch a 6 minute eclipse in Egypt in 3 years, or here in USA in 21 more years. Because I'd be a 75-year-old man. Hope I can make it that much. On the pause here, anybody have any questions? Yes.
What about the Devil's Comet?
A what?
The Devil's Comet, there's gonna be a comet visible through the eclipse.
Oh, actually, I hadn't known about that. Thank you. What?
Trophy Palms Brooks, so it'll be up near Jupiter.
Yeah.
So it's supposed to be about 5th magnitude, something like that.
10th magnitude. Okay, no, so not naked eye. 5th magnitude.
Just below
Okay.
naked eye.
Yeah, just below naked eye. Again, but
Might do it.
yeah, maybe we'll see it. But looking at twilight conditions though, so it may not be naked eye in twilight conditions. if it's fifth magnitude. Yeah. Yeah. But you can, certain binoculars may pick it up.
Hold on, Stan,
Say the name of the comment again.
yeah, what's the name of it?
12P Ponds Brooks.
12P Ponds Brook is the real name of it.
Did I spell that right?
It's actually in the evening, if you have a dark western horizon, you can see it even right now.
Yeah.
I can't see it, they're using the light.
Yeah, but if it's fifth magnitude, then it'll be a challenge to observe in twilight, which is what a totally eclipsed sky is. But now that you mentioned it, I'm gonna look it up and see if I can find it.
It's supposed to approach the sun like a week later.
Yeah.
So it's goes in a brightening streak right
Other questions? Yes.
Is that part of the triple conjunction?
What?
Is that part of the triple conjunction that's gonna happen?
The triple conjunction. Now, this eclipse is not part of a conjunction. A conjunction is going to be part of will be associated with planets. So you'll have a lot of planets in the direction of the sun, and Mars and Saturn will be in conjunction, but the others will not be. Yeah. And so if you again looking at the sun during the eclipse, to the lower right, Venus, then Saturn and Mars close together. Upper left be Jupiter. And Jupiter is still visible after sunset for a while on April the 8th. The others are hard to see in the morning because of the angle of the ecliptic. Other questions? Yes.
So I guess these lines are the beginning and end,
Yes.
right? Well, what are these big curves around it?
Yeah, the green lines are the green line will be the northernmost boundary. So anyone outside the green line sees nothing at all. You have to be inside the green line to see a partial eclipse. And of course, this is where it's happening at sunrise. So if you're over here, you will have seen it, but the sun will rise after totality. You're going to miss it. And here over here, the sun sets before totality would reach you. So you can imagine the people over here in the Pacific won't see it over here, but yeah, these are just the boundaries. If you have to be inside the green path to see anything at all. And I've zoomed in on the path, so you can't see the northern boundary. You can see southern boundary here. And that one, of course, that's the southern boundary, but there's no northern boundary because that's happening again with like this. So the shadow is right here, and the northern boundary of the shadow is actually above the earth due to that geometry. And again, the one for this part, you can see the this eclipse, southern boundary and northern boundary. Actually, northern boundary looks weird because northern boundary for this eclipse, it looks like this. Northern boundary comes up and includes North Pole. And so that a lot of times you look at these maps, which are Mercator projections. If the swath of Earth covered by the partial eclipse includes North Pole or South Pole, it'll look weird on the map. Or if you have an eclipse like in August, where because the Earth's tilt, it goes like this. It goes from Greenland to Spain. It's a straight line right there. But because, of the Earth's tilt, that's how it does it. And then it looks like this. Other questions? Yes.
So according to this map here, the 2026 eclipse will start in far northern Russia
Yes.
and will then move up over the North Pole or thereabouts. And then
Yes.
go back down.
So basically, the moon's shadow will land to Earth, will land here and move to the let's see, North Pole is tilted toward the sun like this. So it goes kind of like this, and it goes down and it goes like this. Yeah. When the path includes the poles, the geometry looks weird on the Mercator projection. Other questions? well, let's do our anti-cloud dance or whatever so we get clear weather on April 8th of 2024. And I want to thank you all for having me. I return control of the meeting to your presiding officer.
Thank you.
All right. Thank you very much, James. That was a great presentation. Oops. Let's see. Okay, Ron, would you like to say a few words about the DVD library?
Sure. The ones you see on the left up there are the great courses, and be aware they're like 10 hours long, 10 lectures, and they're pretty incredible. So the ones on the right, they're called Infinite Cosmos. They're by Astronomy Magazine. Probably about 80% of our library is, in fact, and they're only 45 minutes long. We also have moon maps, planispheres, and pocket atlases. What I'm going to do is go ahead and buy, since a lot of people don't have DVD players anymore, I'll have them available. So you do take it out, that you can take the DVD player with it, plug it into your USB on your computer. So anyway, you're more than welcome to the library. Thank you.
Thank you, Ron. And so we're, in a few minutes here, we're going to take a break and you guys can run up there and get yourself a DVD. I've got mine right here, 400 Years of the Telescope. Okay, so he's got some good titles up there.
Did you put radio telescope?
Oh, I wish. I'll settle for the optical ones right now. Okay, so the meeting after the meeting, after we get done here, we have a meeting after the meeting at Mod Pizza. So you come out here, you shoot up Middlebrook, up to Clear Lake City Boulevard, take a left, go past El Dorado, and right in front of HEB there's a Mod Pizza, and we'll all get together. And I think we have some Mod Pizza experts here tonight. There they are, those two guys. Audrey and Josh. Believe it or not, we're recruiting from Mod Pizza, guys. That's the next generation of astronomers right there. They saw us, they said, these people aren't right. We want to be like them. So they're not coming to our meetings, which is really great. We're glad you guys are here. Anyway, so we'll go get up there and we'll recruit some more astronomers and eat pizza and have a fun time getting together. Everybody's invited to come to that, of course. So we are going to take a short 10-minute break. You guys can go get yourself a DVD, talk to each other for a little bit, and then we'll fire up the beginning of our next part of our meeting. We're going to have our young lady from the United Kingdom, Rosanna, who's going to tell us all about zodiacal lights. So that's going to be a lot of fun. See you in 10 minutes. Okay. I can't believe we're doing this. That's great to talk to you about.
Hey, Rosanna, are you there?
Hi. Can you hear me?
I can hear you.
Okay.
Oh, no, we're not doing anything. No, we already, the leaders. Yeah, unless she brings,
We're not doing that. We said we can do this. So we're going, if it falls out, so you do that, no fall, no break. And then that one, so you know, I'll get with you about
This is shot right. How have you been?
Okay, yeah, got a new toy.
It's new track possession head. So
This one is straight wave here, so it doesn't have any back. Go play.
Seems about across the board where you're going to enter into some locations.
Okay, go down this hallway to the big opening, go to the left, and it'll be on the right.
Okay, we're going to start the meeting. We're going to start the second half of our meeting. Okay, we are really going to start the second half of our meeting. I get to work. Yes. We're trying to start the second half of our meeting. I'm not kidding. I'm going to come around one by one, get you guys to be quiet. Okay. Thank you. I feel like a school teacher here. All right. So, is she ready to go?
She's ready to go.
Okay.
All right, you're there, right?
Yeah, I'm here.
Okay. So we're going to do something we have never done before. We have a speaker from the United Kingdom, Rosanna Howard. She's actually a junior in high school. Is that correct, Rosanna?
Yeah, that's right. Yeah.
Excellent. And I wish I had gotten her bio. I could tell you a little bit about her. If you want to introduce yourself, that would be great. But take it away, Rosanna.
Hi, I'm Rosanna. I used to live in the US, which is how I got involved with the society. but I recently moved back to the UK, which is why I'm doing this online. I've always loved space and astronomy and everything, so I just wanted to do a presentation about it. So this is about zodiacal light. So the reason I decided to do this topic in the first place is because I went to Astrofest recently, and I picked up a book on the radial velocities in the zodiacal dust cloud, and I thought it was fascinating because a lot of the topics discussed in there, I felt like I could somewhat understand with my knowledge on physics at the moment from my school. For example, this diagram here of a Fabry-Pérot infrometer. So it kind of inspired me to keep on reading about it and learning more about it. So here is some screenshots from that. So what is zodiacal light? Zodiacal light is a diffused cone of light that's seen in the western sky and can be traced far along the ecliptic. It comes from sunlight that reflects off cosmic dust particles drifting through the inner solar system and is sometimes called false dawn. The Poynting-Robertson effect causes the dust into more circular but still elongated orbits, while spiraling slowly into the sun. So a continuous source of new particles is needed to maintain the zodiacal cloud. Comet dust generated by collisions among asteroids are believed to be mostly responsible for the maintenance of the dust cloud producing the zodiacal light. So the sunlight hits the zodiacal cloud and reflects onto the Earth, which is why we see this beam of light. So when is the best time to see it? The zodiacal light is most visible around the equinoxes because the light follows the ecliptic or the pathway of the sun. You've got the best chance of seeing it in the west after twilight in the evening, and it's best seen during the weeks of the equinox in March, so around March 20th. You can see it the best from about February 20th to March 12th of 2024, so around this sort of time. So interplanetary dust. The particles of these dust can be from around 10 to 300 micrometers. The ecliptic makes its most extreme angles of the horizon around the equinoxes, which is why the zodiacal light is brightest during this time. So some previous research about zodiacal light. In 1683, Giovanni Cassini discovered zodiacal light, and he correctly assumed that it was the result of a small cloud of dust particles surrounding the sun. He's also famous for some other things like determining the rotation periods of Jupiter and Mars, and he's a very famous astronomer from France. So on the left are two pictures of zodiacal light. They were taken about 150 years apart, so people have been fascinated by this for a very long time. According to the Survey of Radical Velocities in the Zodiacal Dust Cloud, the book I got, the maximum intensity of the zodiacal light is greater than the brightest parts of the Milky Way, which I think is quite impressive. In the middle is a graph by the Sky and Telescope, which shows that comet dust is more likely to cause zodiacal light rather than asteroid dust, based on an experiment they'd done. And the equation on the right is from a 1977 study from the University of Michigan, and it describes the zodiacal color ratio ratio relative to the sun. So when astronomers measure the flux of an object at 2 or more wavelengths, they need to take the ratios of the fluxes. So for reference, the sun's BV index is about 0.65, and this study showed that the color index of zodiacal light was about 0.7. So it's like redder than the sun. And the other equation shows the brightness of zodiacal light, which the first part, that complicated FRN, which I'm sure some of you understand, but not at this stage of my studies, I don't. But that's basically the solar flux distance, R, from the sun. The A is at the albedo, which is a fraction of the light that is reflected. The phi theta is the phase function at the scattering angle of theta, and dl is the increment along the line of sight. The Space Telescope Science Institute in 2015 said that the brightness of the zodiacal light depends on the scattering angle and the line of sight of the observer. It also depends on the composition and structure of the dust particles as well. At heliocentric latitudes between 130 and 170 degrees away from the Sun, it's faintest due to the large scattering of the angles and the lower densities of interplanetary dust. So that's just a little bit of things I've learnt about zodiacal light. I thought it was quite interesting. So I hope you enjoyed. Thank you.
Anybody have questions for Rosanna? No questions?
What time is it in London?
What time is it in London?
Oh, it's 2:30 in the morning.
Oh my goodness. You are a serious astronomer.
Oh, I didn't realize, but I'm dedicated, so.
Any other questions for Rosanna?
Can I just make a comment that I'm impressed that she would do this and pick up a book and go look at something and put it all together and come and speak to a group like this. That is impressive.
That is. Yeah, we really appreciate you doing this, Rosanna.
I appreciate it. Thank you.
Okay, hold on.
Yes,
Question up there.
question. How did you find the book?
Pardon?
How did you find the book?
It was at Astrofest, which is like an astronomy festival in the UK we have. And they have like these little stands and different companies and people share their like experiments and their company and things. And some of them have them laid out on tables, and I just found it like that.
Okay. Any other questions for her? Okay, great. Well, thank you very much.
Thank you.
Okay, great. And we're going to take a minute, and Trevor's going to switch us back here. I feel like there's somebody standing behind me. What are you doing up here? Okay, I think Phil is our next speaker. Are you our next speaker?
Yes.
How do you know that?
Because you showed us the agenda.
Somebody paid attention to the agenda. How do you know? Okay, so yes, this is Phil Stewart. He's actually going to be our next speaker when Trevor gets it all going. We actually discovered Phil. He was sitting in the back row of this auditorium for years. We didn't know who he was, and we found out he was doing all kinds of cool astronomy projects. So then we started asking him to come and participate. And if any of you guys or another Phil sitting out there, and you're doing something really cool, some kind of astronomy project like you, John, I know you're doing stuff.
It doesn't have to be that cool.
Yeah.
Mine's not that.
John's been holding out on this for years. He's been here longer than I have. If you got something really cool that you'd like to show the group, let us know what it is. Or Carrie, I think Carrie's holding out on us too, actually. If you guys got something, let us know. You could do a members minute or a DIY astronomy and dazzle us all with your knowledge and, insight. You ready to go, Trevor?
Just a second.
So, you guys want to ask Phil any questions before his presentation? No, I'm just kidding.
Okay, so here's the advance.
Yeah, thanks. Okay, so I'm going to zip through. I had Rosanna's presentation here just in case something went kaplooey. All right, so next up we have Phil Stewart with 2023 Eclipse movie.
Okay, this is just a little fun thing I did at the.
Do you see how to advance it?
Oh, yeah, the little clicky thing down there. That'll go.
Yeah, you just click on that.
Yeah.
There. Okay.
Yeah, well, we had the annular eclipse like James was talking about back in October, and I originally wanted to drive down into the path and see the complete ring around the sun, but that fell through at the last minute, and I had to watch it from home, which I had about 85% coverage. And so I had more toys at home, though, so I decided maybe I can make a time-lapse movie of this that looks kind of cool. So I slapped something together in the morning as fast as I could and got it finished just before the eclipse started. And I thought I'd show you the result of it. Not as good as it could be, but it's better than I'd hoped. First off, this is the equipment that I used. In fact, I took this picture just the other day and the sun was hitting my lens coming in the window and it made these little streaks. It looks all sciencey. But
This is a telescope for looking at the sun in hydrogen alpha light. It's one specific wavelength over in the red that allows you to see things in the upper layers of the atmosphere around the sun, what they call the chromosphere. And this is a Coronado PST, Personal Solar Telescope, one of the cheapest solar telescopes you can buy. That's the silver tube in the middle. There's also, this is a double stack. It's got an extra filter on the front to give you more detail. And I have modified it some. This telescope's really made to look through visually, which I'm not really a visual observer much. It doesn't work well for photography, so I whack the back off and put a different focuser on it here. And I've got this little camera mounted back here to take pictures with it. And that's what I use for the movie.
Okay, hold on, I got questions.
Sure.
What focuser is that?
It's a GSO,
Okay,
just a cheap $100.
but actually, it's made for the Coronado?
No, not at all.
Oh, you just adapted it somehow.
Yeah, this is the front part of the box. This is the Coronado, which I hacked off with a hacksaw and then flattened with a CNC router. And then this is a 3D printed stainless steel centered metal adapter that I printed. I wanted to play with this metal centering filament. Printed that thing, had it sent to the company. They turned it into metal, and I made that to an adapter.
Yeah, that's not made for the Coronado, is it?
No.
Okay, no. Okay, and up here near the front, near the objective lens, what is that little silver knob? Yeah.
Oh, this is for tilting the front Etalon, the filter a little bit. You get reflections and you can get doubled images of the sun and that kind of thing. And so you have to tilt it a little bit to try to get those reflections out of the
So
field.
that's just the way it's made?
Yes.
Okay, interesting. And you can actually tell a big difference by tilting?
Yeah. You can. And adding just this second filter on the front. The main Etalon is in here. That gives you the really narrow wavelength, and this thing narrows it even farther, and it makes a big difference.
So, okay, so where's the HA filter in this?
Well, it's really 4 parts.
4 parts.
These 2 Etalons give you just a little HA frequency plus other frequencies like every 20 angstroms. It gives you kind of like a comb. Then there's a filter back in here that's a cheap HA filter that blocks out all those other ones. It allows that middle one to pass. And then there's a third filter back in here that reduces intensity some more and gets rid of the rest of the UV to make it safe to look at. In my case, I'm just doing pictures.
Okay.
So this scope is mounted on this little mount here made by Skywatcher. It's called a Solar Quest. It's made strictly for doing solar observations. It's really nice. It's only alt azimuth, but you plop it down. It's got GPS. You turn it on. It figures out where the sun will be, moves towards it, and under this little lens cap, there's a little camera that finds the sun and centers the sun automatically and then tracks it. So you just punch a button and boop, your telescope's pointing. It's very nice. The only problem is it's alt azimuth, so the sun over the 3 hours of the eclipse rotates, and I had to write software to undo that. But at any rate, so this is what I used to make the movie. And what my goal was to take pictures like every 15 seconds to make the movie, but I couldn't get the software doing it automatically quick enough because I was running out of time. So I ended up doing it every 3 minutes, just manually taking the pictures. And this is the movie. The moon going, you obviously see the moon, see the sun with some detail on it. And this should loop, hopefully. One kind of cool thing you can see with this telescope, one thing, you see a little bump over here on the surface of the sun. That's one of the prominences. That's about the only one you can really see with this exposure. You can see these dark lines in here. These are called filaments, which are the same things as a prominence, but they're superimposed in front of the sun. Then these bright plagues in here. These areas are very interesting. One of them's next to a sunspot. The moon could get in the way. Little sunspot here. And there's actually some motion going on from these guys that I was kind of surprised to see. And so I've zoomed in on the first half of the movie to show that in more detail. And so you can see this stuff shooting out of the sunspot. And this over here is very interesting. It all brightens up dramatically, and a little loop shoots out, comes back in. And there's a few little things popping off the surface here and a little thing up here that gets bright. But so that worked out better than I thought it would. Other people have taken much better pictures of this telescope, and I'm getting closer. My final movie, which I don't think works. Let's see. Yeah, it's working. It was. Well, sort of. This is just the first frame and the last frame of the movie, and it's supposed to be going to second for each frame, but it's a little jumpy. But it can show you the rotation of the sun. It takes the sun about 28 days, looks like, from here to rotate once on the axis at the equator. In 3 hours, though, you can tell that it was rotating. So that was my little movie. That's what I've got.
That's, okay, you said it takes 28 days for the sun to rotate.
It looks like it 28 days at the equator. It's really more like 25, but we're going around the sun, and that makes it look like it takes longer.
That's coincidentally close to the same time as winter.
Mhm.
Yeah, interesting. Winter cycle.
And I could be off a day or so here, but it's something on that order. It takes like 35 days near the pole.
Oh, okay.
It's not the same everywhere.
All right.
But really, that other movie's a little bit more. Well, if it runs. Anyway, that's what I've got. Anyway. These were about 2,000 by 2,000 pixels across these images, and it's 30 minutes across. If you want how many arc seconds per pixel that is, I'd have to calculate that. It's just a black and white astronomy camera.
So some kind of ZWO camera.
Yeah,
like
it's an ASI 178 mm.
ASI 178.
mm for monochrome.
It's actually a square format?
No, it's not. It's rectangular, but I made it square.
Okay.
Yeah, I had to do the thing where I rotated it. First off, I had to line up all the sun images because they were moving around. This thing was the mount was trying to keep the sun centered, but of course, as it got covered, it moved the brightest parts to the center, so it was moving all over the place. And I just made it square. It had software center it all, and then wrote the software to unspin it.
So did you have to manually align all of them?
No, I let PixInsight has a thing where it can,
PixInsight did it.
yeah, it can find the edges of the sun, and it did a pretty good job. I don't know if you noticed in the movie, it does bounce around a little bit.
A little bit. Did it rotate them for you also?
No, I wrote my little thing to do that. Just took the times.
Right. Okay, you had to do the rotating, so PixInsight didn't do it.
There might be a way it can do it, but I just did that separately.
Okay.
Okay.
Okay, good. All right, so remember, if you're a Phil out there and you got something really cool you'd like to tell us about, don't be shy. We'd love to, more people that participate, the much better our meetings are. Okay, all right, so celestial objects at 1409 megahertz. Okay, so in the past, I've been showing you guys these radio astronomy projects, and they've all been associated with looking at neutral hydrogen line at 21 centimeters or 20.4058 megahertz. So when I look at a spectral emission, what we see is something roughly around one frequency. So I see this kind of characteristics here. There's going to be some frequency and there's going to be some spread because of all the reasons I've told you in the past. And if you don't know what I'm talking about, it's too bad because I've already done a million presentations about this. But when I'm doing spectral lines, I've been showing you radio astronomy projects about spectral emissions so far. And so you guys might be thinking, okay, I can do neutral hydrogen with a radio telescope in my backyard. Well, what else can I do? That might be something you've been thinking. Anybody been thinking that? Jerry, okay, Jerry, I saw Jerry thought it. I saw his eyebrow went up. He's been thinking it. Okay, so another thing you can do, instead of looking at just individual emission lines, you can also look at or broadband celestial objects. So most celestial objects actually have continuous emissions over many frequencies. They're not just a single frequency like a emission line. So for example, Cassiopeia A has, you can see this line here, it actually has, has flux density over many wavelengths. Same thing, Cygnus A, the sun, the moon. When you see a line like this where it's going from the lower left to the upper right, that's a indication of a black body radiator. So when I look at the moon, I'm actually looking at a black body radiator, something we're looking at the heat from the moon. The sun is a black body, but in addition to it, also puts off other radio emissions. These other ones where they are sloping down to the right, that's not really black body. That's caused by other types of radiation, such as synchrotron radiation and other things like that. So instead of just looking at an individual emission line like I've showed you in the past, now what I'm going to do is I'm going to show you one where we're actually looking at a band of frequencies, and we're going to look at these objects as they come into view and go out of view. And then this is a slide. This shows some other ones like M31, the Andromeda Galaxy. That's what its spectrum looks like over those frequencies. And maybe 7, Cygnus A, and Cassiopeia again. And the Orion Nebula is kind of different. These H2 regions, they don't have like a straight line. They usually will slope up
to the right. So that's the indication of that's where its black body radiation characteristics are. It's its thermal, and then it will flatten out. So most H2 regions has spectral characteristics like that in the radio. Okay, so this slide has, I wonder how this is going to work with this. Oh, it worked, thank goodness. Okay, so there's a lot of stuff going on here. Let me explain all of this. Okay, over on the right-hand side here, this is K-STARS, which is a planetarium program. And what you're going to see is you're going to see our targets come by. There's Taurus, so you see Crab Nebula, right there's the crab going through this circle. And then pretty soon we're going to see IC 443, which is the jellyfish nebula. Those are the two we're going to be looking at. The big circle here is the field of view of the radio telescope. Okay, so radio telescopes, their field of view is way bigger than an optical telescope. So this is a planetary program going over here. In the lower left-hand corner, this is the spectrum centered on 1409 megahertz. It's 1 megahertz bandwidth. And you're going to see this blue line is going to be going up and down as the emissions from these objects come and go. And in the upper right-hand corner upper left-hand corner, excuse me, is the graph of the one in the lower left-hand corner showing the flux density of these objects as they move through the field of view of the radio telescope. And then right in the middle, there's a picture of the radio telescopes that's being used for this observation. So what you're going to see is if you watch the graph on the upper left-hand corner, you're going to see a peak at the Crab Nebula, and you're going to see a peak at the Jellyfish Nebula. So here comes the crab, comes along there, and there's a peak. And then the jellyfish comes along, and there's another little peak there where the jellyfish is. So this is another thing you can do with a radio telescope in your backyard. You can set up and you can look at these celestial objects, and you look at them at these bands of frequencies where they are emitting. Okay, now, all right. So up in the left-hand corner, there's a picture of the Crab Nebula I took a long time ago in my backyard with my telescope. In the upper right-hand corner is a picture of the Jellyfish Nebula, so you can see what we're talking about. Those are both narrowband pictures, which is why you can take them from around here. They're both, hydrogen and oxygen and sulfur, the typical narrowband filters. And then I've shown here on the graph the peak where the Crab Nebula is and the peak where the Jellyfish Nebula is. The Crab Nebula, I couldn't find one that's exactly 1409 megahertz, which is 1.409 gigahertz. But closest I could find is 1 gigahertz. It's about 1,000 Janskys. A Jansky is a unit of flux density. So it tells you about how bright these objects are going to be. So M1 is about 1,000 Janskys, and IC 443 is about 185 Janskys, but it's closest one I can find is 958 or 0.958 gigahertz. And you can see the peak is smaller for the jellyfish than it is for the Crab Nebula. All the other stuff has to do with system noise and system drift, but you can actually get peaks where these celestial objects are. Those are both supernova remnants too. Both the Crab Nebula and jellyfish are both supernova remnants. Okay, now here's another one. This movie's a little jerkier than the first one. This is before I figured out exactly how to make these movies better. But on these, we're going to be looking for two other things. We're going to be looking for Cygnus A, which is right there, and Cygnus X, which is over here. So when this thing comes zooming by, you're going to see down in the lower left-hand corner again, this whole line, just the whole band of frequencies. This whole 1 megahertz band is going to be going up and down when these things come into view or not. And in the upper left-hand corner, there's going to be this plot of the flux density as these things come by. So here comes Cygnus A, you see that peak right there. And Cygnus X, there's that peak right there. And I found out just today that the North American nebula, and this is an area you guys are probably familiar with. You're going to see North American nebula come by, and it's definitely bright enough in the radio that I can actually get that one too. I just figured that out today. And that's Vega, and you guys have probably seen the movie Contact, right? And they're looking at Vega, and they say, people have been looking at Vega for years. There's nothing coming from Vega. Well, I keep getting a signal from Vega, and I'm not ready to say there's a signal coming from Vega, but I'm telling you, every time, 90% of the time, this thing goes by Vega, I get a radio signal off of it. So I'm not doing that yet, but it keeps reminding me of that movie Contacts. So they got a radio signal from Vega. Anyway, so there's the Saturn Nebula. You guys see there. There's the North American Nebula. There's Deneb, Cygnus.
You guys have been out looking at the sky, you're all familiar with that.
Okay.
So is that circle for the beam width of your dish, is that calculated or just, or estimated, or?
It's both. It's calculated, and I confirmed it by testing. I did a sun pass, I've done the moon, and it's dead on. I mean, if you calculate, it winds up being about 7 degrees between, half power bandwidth is 7 degrees, and that's about exactly what it is. Yeah. So thank goodness we got that one right. But Chris, the thing is, 7 degrees resolution is just awful. You think about, an optical telescope, I'm looking at 1 arc second. That's my resolution, 1 arc second. With a radio telescope, it's 7 degrees, is the resolution of the telescope. So it's way different. And you know all that. So I know you know that. Okay, so these are not my pictures here. The first ones were my pictures I've taken. These are off the internet. Okay, so Cygnus A is a radio galaxy. You can see the peak over here, Cygnus A. And it's about 1,500 Janskis, roughly near the frequency that I'm detecting it. And in Cygnus X is this giant star-forming region. It's 5,000 Janskis. It's huge, near the frequency where I'm detecting it. It's big and it's very bright in the radio. That's what it looks like. And when we look, we look at it with our eyes. We're going to back up a minute if I can do this. If you look at it with your eyes, you don't really see. Whoops. Hold on. I might be fighting nature here. Okay. If you guys Trevor and others have, photographed this area, but when you look at the Satyr Nebula, or Satyr, right next to it, this is Cygnus X, it's all in black, right? It looks optical, it's like this big black blob, but it's a gigantic star forming region, and it's really bright in the radio. But it's to the left, whichever way that is, maybe east, the Satyr Nebula, which many of us have photographed. But it's a really bright radio spot right in there, and we're bright in the nebula. So even though it's dark with optical, it's very bright in radio. Okay, and those are, the Cygnus A is a radio galaxy, Cygnus X is a star forming region, and that's that. Okay, this is what this particular incarnation of the radio telescope looks like. You guys have seen this before, you've been here before, but it's a 2.1 meter dish that I built in the backyard. And then this one, Jerry, is this is my newest one. This is a cylindrical waveguide antenna, but I flared the end of it. I put a 6 to 7 inch flare on the end of it because of a bunch of reasons, which we could talk about sometime. And then I've got a Nolec H1 low noise amplifier sitting right on the antenna, on the feed antenna. So that's the version of this thing. And I know at least 2 of you are interested in this. If I can get this to work. Uh-oh. Okay. This is the Nano VNA. This is for you, Carrie. It's for you, man. Okay. This is the Nano VNA plot on that particular horn antenna. So my markers are actually at 1419 megahertz. So 1409 is a little bit to the left of that, just a little bit. But up there in the upper left-hand corner, the radiation resistance is 51.5 ohms. We'd like for it to be 50, so that's pretty close, getting close. And then the standing wave ratio is 1.29. That's the turquoise one. And we'd like for it to be 1, but that's about as good as I could get. And that all had to do with tuning that horn antenna by taking the cap on the back and pulling the thing back and forth and tuning it, and also changing the height of the quarter wave antenna by sanding it down or going too far and have to put a new one in there, but fiddling around tuning it. But that's about as good as I could get this one. But it took a lot of tuning of moving stuff around to get it at least as good as this. So you guys might be thinking, why do you want to do this? There's my webpage. There's a lot of things we can do in astronomy. Optical is great. We can go out visual observers. We can do astrophotography and everything. But this radio astronomy is pretty cool too. And some of us have gotten interested in that recently. But I've been showing you guys all hydrogen line stuff so far. And you may be wondering, what else can you do? Well, this is something else that we can do with a radio telescope in our backyard. That's the point.
You guys believe it? I just love looking at your guys' faces. Every time when I do these radio astronomy talks, some of you guys are like, oh, that's the coolest thing in the world. And some of you are like, oh my God, would he shut up? You know, so it's hilarious. I need to get a camera and take your guys' picture. Okay, anyway. All right, so next up, we got David with Star Party News.
Oh, wait a minute, Trevor's got a question. What's your question?
I said, did he disassemble his chimney to get the?
No, but it is the same.
You can find new ones.
Do you have a question?
Well, I got a question, I guess.
Oh, wait a minute. Okay, I'm sorry. I didn't know if I had a question.
Reeves past questions.
Okay,
What are you using, what are you running the output from the LNA into?
Okay, I'm glad you asked me that. Okay, so the LNA is running into a software-defined radio. Are you familiar with those lanes?
Yeah.
Yeah, software-defined radio, now tuning these frequencies with software-defined radio. Software-defined radio is hooked up to a Raspberry Pi.
Okay.
And so the Raspberry Pi sits outside in the yard all night and day long, so I'm not gonna leave my computer out in the backyard, which is what I used to do. And the Raspberry Pi is operating as a driver server to transmit over the Wi-Fi to my laptop that's inside, and that's where I gather everything.
Okay. Now, is your SDR, is it tuned to the 1409? Yeah. Oh, it is. So the LNA it's not mixing or anything.
Oh, okay, yeah. Now the LNA is an amplifier that's also tuned to this certain band. It's got about, I think it's about 30 megahertz bandwidth or so, around 1420 megahertz, you know, for the hydrogen line. But what I'm doing at 1409. The reason I picked 1409 is because it was I didn't want to be at 1420 because I'd be picking up hydrogen. There's hydrogens everywhere. So you just got to pick that up. 1409 was someplace I could get away from the hydrogen, but also it was a quiet area where there wasn't a whole bunch of other man-made signals. I kind of tuned around until I could find something that was quiet. So it's, you know, antenna, LNA, software-defined radio, the Raspberry Pi, and that's used as a driver server to transmit, you know, into the laptop that's inside.
Okay.
Does that make sense?
Yeah, perfect.
Yeah, I've shown that before. Okay, is there any other questions?
Well, I had some questions. See, your y-axis was in D, you said dB, is it actually dBm?
It's dB.
Oh, yeah.
Okay, Kerry, that's an excellent question. Okay, here's how these you're familiar with software-defined radios, right, Lance? You're not gonna help me. See, he's not paying attention to me. So, the software-defined radio, have you fiddled with these things yet?
Yeah, I have.
Okay, so on one, it says dBFS, which is dB full scale, which doesn't mean anything. And then the little thing on the left I had is just dB, like, who knows what it's referred to.
Right.
Yeah.
So there's gain settings and stuff like that. So
Yeah.
there's a way to figure it out.
Well-
But also the range was only fractions of dB.
Okay. Yeah.
And you know, if it's really 50 dBm, then your low noise amplifier doesn't do anything for you anyway.
No, there's no low noise amplifier, I'm not seeing anything.
Okay.
Yeah.
So, all right, then it's certainly not dBm.
No, it's not dBm, it's
dB full
dB,
scale.
it's dB question mark. It's the same thing, okay, if you're using, SDR sharp.
No.
Well, an SDR sharp, all it does is tells you dB full scale, but you don't know what it
Well,
really is.
that's for your ADP converters.
Right.
But you have several gain steps in front of it, and those are your settings somehow, so they
Yes.
add 20 dB here.
Right, but,
So, yeah.
but here's how the gain setting works. Okay, the gain of low noise amplifier is known because if you look on the data sheet, it's 40 dB gain on this low noise amplifier. When you go into the SDR sharp, which is controlling the software defined radio, all it says is gain 0 to 21, but you don't know what the units are. Because it's just like those dumb ZWO cameras. You got gain and you don't know what, you know, the gain is.
The gains are dB.
I don't think so. Well, it may be, but it doesn't say dB. It just says gain.
Well, if it says, oh, it's either linear or dB.
The truth is I don't know. It's really don't know.
All right, Right.
Carrie, you know, I really don't know what I'm doing. You should be able to figure it out by now. This is,
You're doing it anyway.
I'm doing it anyway, but it's fun. I'm trying to, you know, it's amateur astronomy, right? It's kind of fun. But if you can figure it out, let me know.
Talk about it.
Okay. Any other comments, questions?
Just need to find a calibrated source and quantify your scales.
Okay, so help me with that. How would I calibrate that thing? Calibrate.
You have to go to a calibration lab and spend lots of money.
You don't need to be.
Or just a known source.
I used to have all that equipment at work, but I don't work anymore, so I'm not actually.
I don't know.
But also it's all wide band, right? So I guess the sun is wide band, so you're just saying that's the temperature of the sky or something.
Right, it's a temperature of that object as it passes through. And obviously the beam width is way bigger than the object is.
Yeah.
So the object's gonna take like a tiny part of the beam.
But there's no frequency, different, there's no spike.
No, there's no spectral lines, it's just broadband. It's just like the grass I showed you, it covers the whole, it's like a straight line, so that whole band is just basically, you know, just goes up and down with the object under review. Is that what you're asking?
Yeah.
Okay, Lance.
Just quick, how do you point your telescope, radio telescopes?
Okay, the thing is, it's set on the meridian. So all I can do is I can point north and south, I can check declination, or, yeah, so however you want to look at it, either declination or latitude, however you want to look at it. I know that my house is 29.5 degrees, you know, latitude. And then I know the declination of this object that I want to point at. And I have a little protractor that's stuck on the side of the thing, and there's a weight that hangs down. And so then I move the thing up and down until the protractor reads whatever the number's got to be to get it pointed in the right declination. And when the thing comes over, just like I showed in that video, it goes through the beam width of the antenna, you know, then you get your target. Is that what you're asking?
Yeah, exactly.
So you're letting the targets come to you.
Yeah, because you know, that thing is so heavy, I just barely could put that together. It's a lot heavier than you think it is. So, any other questions? Oh, yes.
Andrew. So once you find something that maybe didn't is out of the ordinary, you didn't expect to be there, can you refine the beam to focus in an area a little more?
No, it's the same as like it's the same as like an optical lens. You know, once you have a fixed focal length lens and a fixed.
You would have to change the whole parameters of your radio.
Yeah, you're just stuck with that field of view.
Get a 1 pixel view through your telescope.
It's a one pixel camera.
Then would you then take your optical telescope and then you can start pointing to look at that area to see what's going on, or?
Oh, yeah. Yeah, absolutely. And that's what they really do. I mean, they find these radio sources and they get the optical guys to figure out what is this we're looking at. So interferometry. Interferometry. Oh, okay, hold on a minute. That's really good. That's really good. So Andrew, that Cygnus A thing, okay, when they first found that with radio, they couldn't figure out what it was. And it took them a long time to actually figure out the optical telescopes with the sound. And mainly because the radio telescope is so, you know, the field of view is like so big, and they say, well, what is, you know, should be going off there? But they finally figured out that there was this radio galaxy. But what Jerry's talking about is you can make an interferometer, which means you can take two radio telescopes and the aperture synthesis, by putting the two dishes away from each other, you can synthesize an aperture that's the size of the distance between the two radio telescopes. So I can put one at my house, I can put one at your house, and then what happens is we could combine the signals from the two, and it would be the resolution of the distance between our houses.
I see, yeah, you're refining your cross, I'm trying to think of the right word right now, like your cross, your direction of looking just a little bit, I guess.
Yes.
But,
okay.
Yeah, sorry. I'm sorry, right now.
The equation for resolution is resolution equals wavelength divided by diameter. of the circular aperture. Actually, it's 1.22 times wavelength divided by the diameter of the circular aperture. That's the Rayleigh resolution for optical, and it's also the Rayleigh resolution for a radio telescope, any round aperture. So the bigger your aperture is, the better your resolution. But you can't make a radio telescope so big that, you know, and what they do now in the real world, the real radio telescopes, they put them on different parts of the world. They put them on one side of the earth, they put them on the other side, and you have the baseline, the distance between these two things on opposite sides of the world, and you get this fantastic resolution. In fact, I don't know if you guys remember, there's a guy that taught that teaches at Rice University that uses the ALMA in Chile, and he gave some really fantastic presentation one time. And those guys are imaging exoplanets around other solar systems, imaging them with radio telescopes, and actually making images of exoplanets around other star systems. And they can do that in radio. In optical, we can get down to maybe 1 arc second of resolution here on Earth. They're talking about 0.001, yes, arc seconds of resolution with radio telescopes. So resolution is fantastic.
So because the atmosphere doesn't affect it, like an optical?
Well, that's true. That's true. And that's the other thing I didn't mention, but I told you guys in the past. You can do this day or night. You can do it when the sun's up, sun's down. You can be cloudy, you can be rainy, you can do whatever he wants to do. And you can still do radio astronomy. It doesn't matter what day or night, cloudy or night, you can still do it.
That's a benefit.
What?
That's a benefit for sure.
Yeah. So. All right. Anything else?
That was very interesting. So, all right, star party. This has gone crazy. We had like two things on the calendar, and we've ballooned up to 2 pages. So, what do I do? Oh,
Oh, you got the little arrows. See the arrows at the bottom?
there we go. Okay, now you can sit down. All right, we had 2 past events that I will talk about. One, Evelyn Medar on February 23rd, and 25th was Saturday, not Sunday, at Challenger Park. There was a little bit of confusion on their end that they admitted originally the date was Sunday, and then literally the Friday before they said, oh, no, we meant for Saturday. So thank you, and I have slides coming up, and thank you for those that were able to make that quick switch. All right, we've got a lot happened this morning. This whole thing got added to the calendar this morning, as well as to the website. Next Friday, Hack Winery, first one up, 6 to 10, and then April 4th through 8th, we've got the club gathering at Fort McCavitt. You can stay overnight for the eclipse, as I understand it. April 18th is up for debate under current discussion right now. Armin Bayou would like us to come out and do a star party, but that's midweek. So we're having the, could you come at 6? Sun doesn't set till 7. Can we work something out here? Or at least try to pull the moon in play? We're having those fundamental discussions. We've got a number of hack dates coming up. Again, an alternate date, not both dates at Armin Bio, but it will either be at the moment April 18th or May 16th. Sliding on, we keep going on. More hack. We got a number of hacks coming up. September 27th to October 5th is Okie-Tex. October 4th, Friday, is another hack winery. Then October 12th, it's going to be Observe the Moon, actually a solar and Observe the Moon night at the George Observatory. This is the old A-Day. 25th through 28th, tentative. Those are in discussion right now with Ken and Lisa Lester as far as possible trip to the fort to tie this trip, daisy chain this one, directly into October 28th to November 2nd for El Dorado. And then right now finishing up November 1st again at the winery. This doesn't include things that'll pop up from Evelyn Meadow Library. They want us back at least 2 more times this year. Same thing for the Challenger 7. They want us back a couple more times. This does not also include schools. Okay, so full calendar. I'm going to keep posting things out. But right now, hack. Things have changed at Hack, as some of you know. particularly the kitchen. Those of you that have attended Hack Winery events, the kitchen has been in flux. Let's suffice it to say, we're going to get drink tickets if you show up. 2 drink tickets for 2 people per telescope. Food, you're going best to play it safe and be now on your own. They will not give us a hard time. In times past, it had been a policy, no outside food brought onto the premises. If you come up with your bag of Whataburger, they're not going to give us a hard time about it because they don't know what they're going to be able to give us consistently for those 7 scheduled events. They said they might be able to bring something out, a charcuterie plate or something like that, or a sandwich, but they don't know from event to event, and they have no problem with us playing it safe. Eat ahead is probably what Connie and I are probably going to do, or bring something with you. Okay. Now, as we were talking about, and as James alluded to, if you want to bring up some, try to remind some old friends, here's the center line. Here's Fort McCavitt. And then April 8th, you gotta hop this line to get over. Well, the Lesters are over here in Junction. You can kind of look them up. But if anybody remembers Triple Nickel, Bob Taylor, and I just dropped his name, Jeff Stone. Look at where Hunt is relative to the center line. Bob Taylor's at Hunt. So we should all try to go visit. So there you go. Don't say I said so, but there you go. All right. 23rd, trying this a little bit different. Evelyn Metter, I want to thank Richard Slater, wherever you are, for the pictures. I was not able to, thank you, sir, not able to accept it. I don't think there's pictures of you in here. So, it's, that's the photographer not being in his own pictures.
Yeah. And the lesson learned, don't wait till it's completely dark to start taking pictures.
You will get no.
They're a little bit fuzzy.
You will get no criticism from me because I'm guilty of that as well. At many Star Party events. So trying to keep track of who is there. So Richard Slater was there, Chris Randall, Doug Holland explaining something. I think there's some fun activity around his scope here. Is that you? That's Doug there again. Reed Klotzer, Stan Lamb. If there's anybody else who is there that I have missed, I will apologize, but I just didn't get a name. I was not able to make this one at the last minute. Chris again, and an interesting C8 there. Then on Saturday, the 25th, over at Challenger, Chris Randall showed up. Bob and Leslie Eaton were there. Reed was there. Because of their little snafu, it was not very well advertised. Oh, wait a minute. I think, Doug, didn't you say we had like 50 people at Evelyn Metter? We might have had 20 at this one. A lot of them were walk-ons. There was a time there for a moment I thought we were going to have more astronomers than attendees. So for organizational sake, we sort of gave them a hall pass, but it was nice to set up and see the park again and kind of reforge that relationship. Again, I thank Mark for being there. Stan, sort of the layout here, my little scope sitting over there. Chris, there's Leslie. And then I never got a picture of Mark Junko, but okay. He was there with a very interesting mount. And that's something we can all relate to. Is that a telescope? Planning on some astronomy? So, all right. Thank you very much. And I'll just keep you posted on the list about the star parties. Doug.
So the A-Day this year, is it going to be any more like A-Day used to be, or what's it going to be like?
It's going to be more like just extended hours for the George. They're probably going to let now maybe about 400 through. The A-Day as we knew it cannot be run with the current HMS rules and guidelines. So we can't have 2,000 people through the door at once. Those kind of days for liability reasons and whatnot, they hold off. That I have punted that to Aaron. If there's going to be an all clubs meeting, Aaron Clevenson is going to do it. He's actually talking about trying to revive doing an astronomy day, Houston Astronomy Day at Insperity. and he's got our backing if we want. And I'm not being critical of the HMNS, but it's just how they decided they wanted to do things post-pandemic. Honestly, Saturday nights were a free-for-all, as Connie and I can attest. Pre-pandemic, we'd have 350 people show up. We wouldn't get out of there till 1 or 2 in the morning. And volunteers were starting to get burned out, including us. When the HMNS opened up post-pandemic, they were only letting 75 people in per hour. Those people come, see what they need to see, out, in come the next 75. And it's a little bit more structured for them. And it's a lot more humane on the volunteers, to be honest with you. But they don't want to go back to the days of having 1,500 through the door for a day. So what I've worked with Kavita to do for Observe the Moon and then the Solar Observe the Moon night is they'll basically, we plan it on a first quarter. So by the time it's 5 o'clock, Lady Luna's up there, it's a target. And we have that open from basically 5 through about 10, no time limit. The people can just come and go as they want. I want to try to connect with the LPI and see if we can get with some of the residual A-Day funds, that big giant moon map they had. They presented it a few A-Days, get one of those printed up and have, donate that to the George and have them put it up for that event. And basically it's going to be a much lower key. We don't have to have the number of volunteers coming out. Oh, and the other thing is every volunteer has to have a federal background check for the HMNS. So that in times past, we used to be able to get away with a Texas driver's license. No, it's a federal background check, and it's a deal breaker if you don't want to do it. They have been going completely through their volunteer ranks. And quietly, we've been told a few volunteers have been dismissed for what things have been found. So yeah, it's, I guess, all for the better. All right. Yes.
I noticed you didn't have the Texas Star Party on there in April for the eclipse.
Is there? Okay. Yeah, you're right. Yeah. I did not put that up there, but that is also there.
This morning, there's still some openings for campground sites.
Yeah.
I'm going, it's April 5th. You have to show up on 5th through I think they let you spend the night over on the 8th.
Yeah.
So on the 9th, you're not fighting the crowds on the highways.
To get out, yeah.
It's like a Border 4 site. It's not as good as Prudent Ranch, of course. But
Where is it then?
it's near Waco, Latham Springs.
Oh, north of us here? Okay.
Yeah, it's up between Waco and Lake Waco.
Okay.
But it's right on the path.
I'll put it on the calendar. Yeah. All right. Anything else? All right. Thank you.
Okay, thank you, David, for continuing to be our Star Party chairman, organizing all that stuff. So, Bob, I need the, yeah.
So we're gonna do door prizes, so get your door prize ticket out. We were here last time, we got some new door prizes. We got this lovely Ioptron mount up here.
No, that one's not any door prize.
Nope. Oh, come on, Trevor.
Trevor got a new telescope mount, it's really cool. But he's being selfish and not giving it away to everybody else. So. Alrighty. First one. Oh, brother, can't see it. 863. 863. Is that you, Mark? Oh, man, get down here.
Another pair of socks.
Okay, Mark, hold on, buddy. I know what he wants, so I'm not even gonna look at anything else. Okay, we got these socks. Okay, Mark got the socks last time.
I got my entire wardrobe here.
You were just talking in the restroom. I told him if he wanted, he could get another pair of socks. Yeah, got the plant socks, got the galaxy socks. I'll give you something else if you don't want the socks.
Well, do you have anything else? Just check.
Yeah, we got a moon map, thanks to David up there. Moon map. We have a bunch of patents like astronomy, the patent on the telescope. You can hang that on your wall in your office at work. We have from Rick over there, STS-98 crew pictures from the space shuttle. Yeah. Oh, I have a 16 gigabyte flash drive. Socks. You need the sock, man. We'll take the Galaxy one. All right, good. All right. We actually put them on at Mod Pizza last time for us and modeled them. Okay, next one. 853. 853. Got 853 here?
My mom.
It's your mom? Get over here, Mom. Come on, Mom. You're Jonna's mother, huh? Wow. That's pretty cool. Okay, so Mom, let's see. Oh, you know what else we got? We have Saturn maps. We have Jupiter maps. We have Mars maps. In case you go travel to any of these places, we need a map. We got a moon map. I've got these socks. Oh man, the socks are a hit. All right, very good.
Thank you.
All right. Okay, Audrey, I'm trying to pull your number here. Why don't you just tell me what it is? Don't tell me. You'll influence my, yeah. Okay, 862.
Hey.
Who is it? All right, Chris. Former president. Okay, so Chris, I got a bunch of patent pictures. You can put them in your house, in your office. They're astronomy related patent pictures. I got a moon map. I got maps of Mars and Saturn and Jupiter. I was trying to figure out where they were under my arm. Okay, Mars map? Okay, so when you go to Mars, you'll have a map.
Exactly.
Okay, let's do a couple more. I'm trying to get Josh and Audrey up there is what I'm trying to do. Okay, Josh and Audrey. 860. 860. And 860? It's David. Oh, I only got one you can have. We have a moon map for you. So David actually makes these moon maps. Yeah, I'm not going to do that. Okay. Oh, I got STS-98 crew pictures.
I will take that.
Yeah, I thought you'd like that. That's kind of cool. That's actually Rick that brought this. The guy, yeah, Rick. All right. Hey, David. Okay, this is probably the last one, even though I really want to give door prize to Josh or Audrey. I'll just have to suffer. How about 851? You guys from the same family. Okay, Ovidio, come on down here. Come on, man. Okay, so let's see. I'm thinking Ovidio, what would he like? I've got some flash drives. They're really tiny though, 16 gigabyte flash drives. Don't want that? I got a Saturn map. I got a Jupiter map. I got a moon map. I've got patents of the telescope. Your mother-in-law took the socks. Oh, you like the pen? Okay, let me show you which one I got. Okay, I got this one. Hold on to those. You hold it. And I've got these here. That's like a dome. That's like a balance. No, that's like
what do you call those things?
Oh, that's a radio telescope.
Oh, really?
What?
You have that one.
Trying to remember the name of it.
You want it? Take telescope. I actually have a T-shirt with that on it.
Oh, yeah?
That's pretty cool. Nice. All right, very good. Thank you. Keep it a souvenir. All right, very good. That's it. So next month, April 12th, we'll be here at UH Clear Lake, and we're going to be doing a series of short presentations by JSC members. So we got several people who have signed up for doing short presentations. We'll be doing that. Thank you very much for coming. See you at Mod Pizza directly after this meeting. That's it. Thanks. We survived. Oh my gosh, I can't even believe that. Yeah, see, who says that astronomy doesn't pay?